At this point, we could go on to optics because we're going to do most of our optics treating light as a traveling wave. There are occasionally normal modes come up, but usually it's a traveling wave. But we'll get a lot more insight if we think about the string a little bit longer and try to think of the interplay between normal modes and traveling waves. So let's see if we can describe a traveling pulse in terms of normal modes. So here's normal modes for a pulse, and I want it to be something I can really make. With my hands, I can make a demo of. So we're going to do this one, where we launch a little triangle-shaped pulse in the string. And you know we can do one because we've sent a few down for you already. Let's see, we're going to say, as always, we're clamped from 0 to L, and we're going to say this goes up with a slope C, and it comes down with a slope minus C. It goes up to a height. No, we're not going to specify the height. We're going to say it goes up at a slope C to a distance L over 20, and then comes back down by distance L over 10. So 1/10 of this length is a little triangular pulse up C, down C, and then the rest is flat. That's kind of like the pulse we've been launching. So one of the challenge problems will be to solve that in terms of the sine harmonics. So it'll look something like this. 1 to infinity, we're going to use bn's sine n pi over Lx. And the question is, what are the bn's? So this is a challenging one. You got to integrate by parts. You got to separate out the integral correctly. It's a lot of work. Let me give you the answer. So that way, if you didn't want to answer that one, here's the answer. You can see if you can get it on your own, though, is 2cl over n pi squared times 2 sine n pi over 20 minus sine n pi over 10. If you make enough terms like that, it'll make a triangular pulse here. It'll be flat everywhere else. So we want to see this pulse move. So to watch it move, what are we going to do? Well, the simple thing might be to say, well, if those are the normal modes that make the pulse, maybe just let the normal modes go, right? So to watch it move, do we let the normal modes go? And by go, I mean, do you multiply them by cosine omega n t? Right? So if this is the function of x, we could just write cosine omega n t and then just let it evolve and see if that gives us the motion, where omega n is the proper n pi over lv times x. Well, not quite is the answer to that question. You could do that, and that'll give you one kind of motion, but there's actually many different kinds of motion that could occur. You could have a pulse in a string that looks like this, and if you just let it go, what's it going to do? It could be a pulse going that way, right? Maybe you froze it in time when it was moving to the right. Or it could be a pulse going this way. Maybe you froze it in time when it was moving to the left. Or if you let this go in time, maybe it would split into two pulses going in opposite directions. Okay? I don't know. What's it going to do? How do we tell the difference between those three things? What it depends on is the initial velocities of everything. Right? So if this pulse is moving to the right, these bits of the string are actually moving up. Their transverse velocity is moving up. And these bits of the string are moving down. I'll put Vt. Okay? And if the pulse is moving to the left, these bits of string are moving up, and these bits of string are moving down. So there's difference in the initial velocities. For this to happen, this would happen if what? If all Vt's are 0. intuitively, you might understand that because you know where's there the biggest curvature. The only place you have a force, if this string is sitting still, there's only a force where there's curvature. There's curvature here, so there's a force that way. There's curvature here, there's a force that way, and there's curvature there. There's a force that way. So if you imagine how that's going to pull, it's going to pull these out and that down, and it's going to make that. Okay? So you can't just slap on cosine omega nt's. You have to actually, it depends on the VT of each section of string. All right, so now let's see how we deal with that mathematically.